Hello everyone, in today's video we'll be talking about the Spring framework and specifically inversion of control, IOC, and dependency injection. IOC is a design principle where the control of program execution is inverted from the main program to a framework or container, such as Spring framework. In traditional programming, the main program controls the flow by creating and managing objects. However, in IOC, the control is given to an external entity, which manages the creation and lifecycle of objects. That brings us to dependency injection, DI, which is a technique used to implement inversion of control. The DI pattern allows a class to receive its dependencies from an external source, rather than creating them internally. See this example. This airplane is a Spring Bean, which is an object instantiated, assembled, and managed by the Spring IOC container. It has dependencies such as wings, engines, etc. If the application needs to use the airplane, it can retrieve it from the Spring context using dependency injection. Okay, so how are we adding the dependency injection? There are three ways to do it in Java: constructor base, setter base, and field base. Imagine a car as a Java class. To function properly, the car needs all its essential parts, like the engine, tires, and battery. The mechanic, who represents the constructor in Java, knows exactly what parts are required to ensure the car can start and run smoothly. If even one critical part is missing, say the engine or the battery, the car won't start at all. Similarly, in Java, a constructor ensures that all mandatory fields of a class are properly initialized before the object can be used. Without these fields, the object, like the car, simply won't work. The constructor injection ensures that all required dependencies are provided during object creation. If any dependency is missing, the error is detected at compile time. Also, declaring these dependencies as final ensures they cannot be modified later, maintaining immutability and stability. The car class shows key object-oriented principles. It uses a private final engine field to make sure the car always has an engine that cannot be changed. The final keyword ensures the design is reliable. The engine is provided through constructor injection, making sure all necessary parts are set when the car is created. With setter injection and auto-wired, it's like the mechanic assembling a car frame where all essential parts, like the engine and wheels, are automatically installed before use. Unlike constructor injection, where parts must be fixed during the car's creation, setter injection allows you to swap out parts later if needed, giving you more flexibility. Setter injection is like upgrading a car by adding features like GPS or a sound system after purchase. It offers flexibility by allowing optional components to be added or updated at runtime without rebuilding, making applications adaptable to changing needs. Here, constructor injection ensures the car is always created with a critical dependency, engine, making it reliable. Setter injection with auto-wired, required equal false, allows the optional GPS component to be added if available, enabling flexibility without breaking functionality. Lastly, we will talk about field-based injection. In this case, the mechanic installs the engine and wheels directly into the car frame, keeping the process hidden. The parts are ready to use, but since they're concealed, replacing or fixing them later becomes challenging. Direct assignment injects dependencies straight into fields, similar to factory pre-installed parts. It's simple to set up with no extra methods, but it limits control, as dependencies can't be validated at compile time, risking incomplete initialization and runtime issues. This code demonstrates field injection, where the engine dependency is directly injected into the field using Chirsek AutoWired. While simple and concise, it hides dependencies and can make testing and maintenance harder. We'll explore why field injection is discouraged. It lacks compile time safety, with missing dependencies only caught at runtime. Additionally, testing becomes challenging due to private fields, often needing reflection or extra tools. Field injection creates immutability issues, as dependencies cannot be marked as final, leaving them vulnerable to unintentional modifications and reducing reliability. Thank you for watching our video. Please don't forget to subscribe our channel.